Hello guys, welcome to another live about non-invasive glucometer monitoring system and designing and fabricating sensors and calculating a glucose level for humans without breaking the hands. Okay, in previous live I have explained about how glucose acts in our human body and also how it categorized into different methods, how the traditional glucose monitoring happens and what are the non-traditional, like non-invasive methods that is used to calculate the blood glucose level. Here we need to keep in mind one thing that non-invasive glucose monitoring is one of a Grail methodology, which is still on progress by biggest tech companies. Even there are a lot of tech companies still working on this technology or still working on this non-invasive methodology for blood glucose monitoring. As you can see, we have latest technologies around the world. One we can say is Apple Watch, one of the revolutionary technology for to monitor the person's lot of things. For example, heart rate, SpO2, sleep tracking, and there are a lot of functionalities inside a small wearable devices. But yet, still we need we need some calculations and research and development for a particular disease, which is nothing but glucose monitoring. In some other countries, we can see there are a lot of devices present, but all those devices still provide a little bit of tolerance in their measurements. So that's why it is called as still under development for this particular disease, glucose monitoring or else glucose blood sugar. Okay, this is what a simple intro about this. Next, I will explain what are the things we have done in the previous slide. If you don't watch that, or else if you have missed that, if you are new subscribers, please do a subscribe and you can always watch that live in the card. I will leave it over here or else in the description or else in the comment section of this video. I will share my screen so you can visualize what we have seen in the previous slide. Okay guys, okay. Okay, in the previous video, the previous live about this glucose monitoring device R&D, we have seen about how the NRA methodology, which is nothing but near infrared radiation technology, which is one of a spectroscopy method for calculating glucose in a human body. We have explained about that. I have explained about that NRA methodology in the previous video with a demonstrative diagram as well as the detailed explanation how it works and how we have calculated the blood sugar with the NRA methodology, NRA spectroscopy. And also I have told about that in the I have taken four papers, four citations from Google Scholar about the latest technologies, what is a recently trend in glucose monitoring. Apart from this NRI, we got four papers and filtered those papers from almost 10 paginations or to 6 paginations. Those papers are in different methods for calculating glucose or blood sugar. One of the paper is more about the machine learning, how to increase the accuracy of the blood sugar by calculating any kind of method by using machine learning, ML or AI. And another paper explains more about the fabrications of sensor unit to sense the sugar or blood sugar present inside the tissue, how to calibrate the sensors and other parts, how to fabricate a new equipment or new chemical product for the sensing part of the blood sugar. Third paper, some of the paper explains about the calibration of using microcontrollers and the sensing part for different skin tones and blood flows. So these by this paper, I have used the Gemini Pro model to summarize and what are the different other ways we can make sure we can get the same accuracy as like that. These are the things we have seen in the previous slide. Now in this slide, what I have done is that I have completed the circuit diagram for that entire script, and also I have read the documentation about certain parts, and also I got the parts. I will explain one by one how it going to be work and what are the purpose of that entire circuit, and what are the purpose of each and every component inside we have used inside the circuit diagram. So since I have told you that we are going to take Gemini and artificial intelligence for our as an R&D companion. This act as my co-mate for and for this entire R&D process. Okay, this is what we have given. So for this, what I have done is that I have combined the methodologies inside the four citations I have provided for this as a prompt. So what I have done here, we have going to use microcontroller and other steps here like ESP8200, sorry, ESP32 and ADS, MCP chipsets, which is something about polarization sheets and etc., which these kinds of requirements are taken from the four citations as a prompt. And I got this here. You can see what are things and approximate value we need to invest for this MVP, which is nothing but this is not this we cannot develop a clear product at the first side at the first try. Each and everything will have a trial, and also we have the fault tolerance and equipment may damage by whether we are going to, because of in some conditions electronic products where we are using some resistor capacitor and all of the stuffs will eventually damage because of the higher or lower voltage we are going to provide. At the first attempt itself, we cannot exactly create the entire product. So what I have to done, first I need to grab some information about what are the equipments I'm going to use. So what is the purpose of that equipment and how it is going to be, how it is going to, how it's going to be useful inside our entire project. What are the use cases by using that? Because of each and every electronic equipment, we have the competitor equipment for that, or else a cheap side or else a premium side, which is going to provide a lot of features. So this is why in while you are working with some electronic or electrical devices, always there is an consideration, or else why we need to choose this equipment over that equipment. So there are a lot of questions here. That's why first I need to get the information about the requirements. After providing the four citations and papers and got some response from the Gemini, here I have the requirements for my MVP, most viable product. First, we are going to make a most viable product MVP for our R&D, and we are going to test trial that with different measurements, and we are going to train an own model to provide an accurate results. This is what we are going to do. After that, we need to calibrate this entire MVP to an product level by via the step-by-step process. So first, our mission here is to create an MVP that works well while we are calculating the glucose values, or else with the different samples. Here we have taken the microcontroller ESP32, the board for our microcontroller, because it has built-in Wi-Fi as well as the Bluetooth connectivity. So why we need Wi-Fi? In the previous video itself, I have explained about because of since we are going to integrate a machine learning on artificial intelligence, so possibly we require some processing as well as the network facility to provide to communicate with those models, or else we need to develop their own model inside our board. And also I have checked about why can't we use ESP8 266. So these two have the similar properties, but do we have a lot of difference while it comes to play ML or AI inside our board? So since we need a strong consideration of ML or AI features inside our application, we need a lot of process. We need a lot of processor processing units, and we need to invest in that. That's why we have chosen this ESP32. Comparing to comparing to that A266, which has the lower processing power, and also it doesn't have enough memory to withhold the MLs. That's why we have gone for this ESP32 dev board, which is going to provide each and every features inside a one. Next, we have this ADC module, which is to analog to digital converter module. It acts as analog to digital converter. So ADS 1115, a 16-bit high precision voltage run reader, which is going to get the analog to digital signals towards our microcontroller board. Next, we got that operational amplifier MCP 6002 DP. So this is the crucial. Here you can see, as it mentioned in the response itself, because of I have thought about why we need to use a MCP 600, because we have already that silent kilopass filter, which is one. But here, Germany suggests one of the important point for me, which is nothing but this MCP 6002 has built into operational amplifiers inbuilt in it. So silent key low pass filter requires only one amplifier circuit, and another one inside this MCP. You can see MCP 6002 doesn't require, which is an waste. Am I right? I will show you the pinout diagram for this. Okay, and see, here you can see. So we got a two amplifiers here. So one thing that is mentioned by Gemini is that we can stage this into two categories. First, this kind of a hop is considered to be stage one, and other hop is to be a stage two. It will be a little bit confusing for you people to see these two things, but in the last of the circuit diagram, you will easily understand why I'm saying this is stage one and stage two. In silent key low pass filter, we do have only one amplifier thing. Let me produce the simplest one here. You can see we got only one amplifier circuit here, and with a bunch of resistor and capacitors. This is a silent key low pass filter. This is used to for the noise cancellation, noise filtration process inside of the signal, which is going to hump the 15 and 60 hertz of noises. This is stage two part inside this MCP, which is nothing but this second amplifier is used as a silent key low pass filter, where we need to connect that bunch of resistors and capacitor with the stage two of this amplifier. But this stage one amplifier, which is pin to 1, 2, and 3 and 4 here, is very much useful for to get an exact voltage values with the different skin tones as well as the blood flow. This is one of the idea that Gemini has provided in the response. Because of using these two things, we can calibrate, or else we can get the exact voltage references for different skin tones. This is important for me because of in the previous hackathon, while attending a hackathon, I have done a lot of mistakes. Now I understand why we got that, why we didn't get that exact results or exact accuracy for that, because of we don't calibrate that results, or else what are the output the sensor gives. That's why we didn't get an exact result, exact accuracy. But Gemini now provides an extra more information about these things. That's why, and because of each and every skin tone colors, or else blood flow inside our each and everybody has a different different structure. That's why this stage one amplifier is going to calibrate those things for us. And after we bought that We are going to process those results with a stage 2 amplifier by cancelling some noises, and we are going to provide it to the ADS. So this is the main functionality of MCP not 2 and DPA. Okay. Next, we are going to use the photodiode, which is nothing but BPW34. You can see BP34. It's nothing but a simple two-pin out photodiode, which is going to grab the signals which is passed through the finger. So the high-speed silicon pin photodiode form from something they have mentioned, but I don't want this. I just wanted to the diagram itself. Yeah. So this photodiode consists only the anode and cathode. Anode and a cathode. The cathode of this is going to be connected with the voltage supply, and the anode of this is going to provide the output to the MCP 006 that we have previously mentioned here, which is going to get the input from this photodiode from the anode side. This is the main thing because this is going to get the remaining rays which is passed to the finger. Next, since we are going to get which is the receiver side, which is nothing but BPW34 photodiode, as we all know that we need a transmitter. So here the red light is going to be transmitted by a laser at the 650 nanometer, which is going to run at a 5 voltage. This is what it looks like. It comes from different components and different wirings, and comes with the different prices too. It has 3 pins, which is nothing but we got 2 pins, for one for the supply and one for the ground, and third one for the signal. So according to the signal, we can what we can do, just say we can reduce or increase the intensity of this laser. So we are going to use a 650 nanometer red laser for this purpose, but I don't consider, or else I don't think about these red lasers, how it going to work, because of while I'm in the hackathon, we have used the LED diodes which don't emit light like these colors. And also, from the research papers of these wearable devices, one of the important thing I have analyzed while in the hackathon, after the hackathon period, I have analyzed why the wearable devices has green color lights or green color LED diodes instead of any other color apart from the red or anything, or transparent colors. Why we got a green color? So in that analyzing, I got some results which is looks like a better concerning for the transmitter. Since our blood color is red, which is going to accept the more suitable color for more suitable ray colors, which is nothing but the green. So that's why most of the wearable devices is they are using the green color over any other color for their transmitting, for the sensing purposes. This happens in the each and every wearable devices. We can say it may be an Apple or any cheap kind of wearable devices that we have in our hand. It is going to calculate heart rate, SpO2, and or else modern any kind of features or any kind of things from our body. But all those things will use the green color light emitting diode, because for the better acceptance of the rays into our tissues. But Gemini here it proposed a red laser. Maybe I need to do some analysis right now. Sorry, which color is most acceptable for blood? Okay, which color light? Let me check this. Both red and green are considered acceptable safe for the use on blood or skin tissues in the context of light therapy. which each color serving different therapeutic purposes. The most acceptable color depends on independent application due to their absorption and penetration properties. Rightly, deeper penetration healing. Red has more a longer wavelength, around 620 to 750 nanometer, which allows it to penetrate deeper into the skin layers and even into muscles and deeper tissues. Wound healing, tissue repair, pain relief, blood circulation. It can enhance blood flow and oxygenation in the targeted area. Okay, and it simulates fibroblasts to produce collagen and elastin, helping with anti-aging and skin elastic. Okay, green light surface level treatment. Green light has a shorter wavelength around 945 to 570 nanometer compared to red and primarily affects the most superficial layers of the skin, upper dermis. It is strongly absorbed bevel. This is what you can see, as I have told. This is what those from the citations I have read about those wearable devices, why it got that green color for their devices. It's strongly absorbed by blood, hemoglobin, and melanin. This is the main reason, key factor, that each and every wearable devices got their green color for the devices. Key uses: hyperpigmentation. It helps fade dark spots. Okay, sun damage and melasma by targeting melanin producing cells. Okay, skin tone and redness. It is effective at calming irritation skin, reducing redness, and even out skin tone. So you can also concern by this point too. It is effective at calming irritation skin, reducing redness, and even out of skin tone, because the devices in our hand, the devices, for example, the wearable devices in our hand, the most advanced devices like Apple iOS watches has to continuously read the data from the human body. So continuous use of red lasers will be affect for the human skins. This is also one of the major important point. They have used the green light. It is effective at calming irritation skin, reducing redness, and even out of skin tone because of red colors. But I don't think our device doesn't record that green, because maybe for the one point we can go for the green hyper, which is something, but it is strongly absorbed by the blood, hemoglobin, and melanin for this one point. But I don't think that skin tone and redness is going to change our color for the MVP model, because we are not going to use it for 10 to 50 times a day. This is not a use case for our application or also MVP. That's why I don't think green color is not much necessary, but for the one point it's strongly absorbed by the blood. That's why we maybe in future we need to move to the green color apart from the red color. If we continuously read through the if we continuously read some factors of the body, then we should move to the green color instead of the red, which will cause us damage, prolonged damage to our skin, prolonged use damage to our skin. That's why they have used this green color. Good to hear. Penetration depth: deep dermis, muscle deep tissues; shallow mid epidermis, upper dermis. Okay, red light and mitochondria and colonal production, blood flow, wound healing, anti-aging, and pain. So comparing to the green and red light, we can say the results for the red light or the scores for the red light is much higher than the green light. The red light can penetrate deep to the skin tissues. This is what we need, because if I place a finger in between the transmitter and the receiver, we need the remaining rays which needs to be provided as an input to the receiver, which is nothing but in our case the photodiode. If the green light doesn't have that much ability to penetrate to the skin, which will eventually fall off, which will not reach the receiver side, photodiode side. So this will be a great loss for us to calculate the glucose. So we don't require the green light for this our condition. We need the red light for our, because of it has a deeper penetration, and also it is going to correlate with glucose, and we are going to get the exact result as we are, because of we need the back end radiation which is remaining output from our or else through our finger. That's why now I consider concerned about this red light. So this red laser, which is necessary in a 650 nanometer. Further, let's move to the another requirement, which is something like polarizer sheet. So polarizer sheets. This is much more confusing to me still now because of not because of this polarizer sheets, but because of how we need to align the sheet in between the two things, which is something about the transmitter and the receiver. At last of the circuit diagram, you will know why I get this, why I get that confusion. Because of in the previous response from the Gemini, it told me to rotate into the 90-degree. So if I cut the polarizer sheet in a square shape, if I move it to the 90-degree, each and every 90-degree will look like the same square. Because of I don't maybe you people think, oh, or you don't understand the polarization. Exactly, I don't understand the polarization because I don't, because in my life I didn't see any polarization sheet, but I heard about the polarization sheet, so I don't know how it works and how it looks like and how it's going to act in the colors. That's why I have a confusion, but that confusion is solved by the Google Gemini in the latest response. I will show you how it works and how it affects and how I got the solution for this. But these polarization sheets are going to use to focus that this laser red laser colors into their own focal point. And also the at the receiver photodiode we need to place another in front of the photodiode, a polished square sheet which is going to be angled in a 90-degree. This is because from this laser, after pointing towards the skin by using the polarization sheet, these rays will tilt or else it will change the direction due to the twisted shape of the blood sugar inside our body. So which will eventually scatter those lights in a different direction. Let me show you how it, what it says and how it's going to be affected. Okay. Imagine this is our skin, and we got and we got red cells flowing inside our skin. Sorry, this is the different size, but actually it does not look like this. Just for the demonstration purpose, I'm pointing. Okay, these are the blood cells, and in between then we got that blood sugars, which may looks like this, which look like this. So if the glucose molecule present inside the blood cells is lower, then obviously we are going to get the light resulted light in a higher manner, which is inversely proportional to this, as I have told you in the previous slide itself, which is because of Breed-Lambert law. If the glucose molecule present in a higher value, obviously it will not produce the light ray as incident in the from the laser ray. So it will reduce it inversely proportional by the Breed-Lambert law, and the intensity of the amount of voltage we are getting in the results will be also the lower. So according to this, we are going to provide the glucose present in the human. Now let's back to that ray concept. So that red light, it will be passed from that laser. Let us consider this is going to be the red laser. Okay, and also we got that thin film square sheet polarization sheet like this. So which is going to focus that red laser in a one point instead of spreading to that remaining open space. It will focal the ray in one point. So here the human is going to place the finger. Let's consider this is going to be the finger, and once again we got the polarization sheet. Once we got the polarization sheet again here, but this polarization sheet is going to be rotated in the 90-degree angle, because once the rays enter the finger, it will be deviated. So let's demonstrate here inside the skin tissue itself. So once the ray is passed, once the ray is passed like this, if the ray is passed like this, the blood cell or the water molecules consist inside the tissue is not the main enemy to deviate the rays, but the main enemy here to deviate the rays is nothing but our glucose molecules itself. So once if the ray hit the blood cell, it's not going to deviate, it will pass through it like this. But if it spotted on the glucose molecules, obviously it will be twisted by the glucose molecules, since the shape of that glucose or chiral in shape, which is nothing but twisted in shape. This is also one of a doubt whether this was clarified by the Gemini in the previous response, while I have also told you what is a definition for the chiral molecule. So once hit, it will be deviated, or else it will be defected in another direction. Some sort of angle will be deviated once it affect this, like this, maybe defected. So obviously it will redirect the entire ray into a different direction. So if you consider in a real-time manner, this after these rays passed inside the finger, and when it came back to another side of the finger, it will be deviated in different directions. Let's say like this, like this. One may be passed in a straight like manner, because since they passed through the water molecules or blood cells, it is not going to be deviated. But if they pass through the glucose molecule, obviously it will be twisted. So something like this. That's why here we using the 90-degree polarization sheet, because whenever the deviated rays hits that polarization sheet, this 90-degree polarization sheet is going to focus the entire different angle deviated ray in one point through to the photodiode. That's why we are using the polarization sheet in our condition here. Next, we got some resistors. We got a bunch of resistors for this purpose, because already we all know that to make the silent key low pass filter, if we record the R1 and R2 and C1 and C2, what are the capacity of this R1 is going to be the 10k 10 kilo ohms of resistor. Both the resistor are 10 kilo ohms, don't need to worry about that. We have got that. Check this results too. 10k means in addition it is going to be the 10,000. Okay, and capacitor, we are going to say it is a picofarads, and also this is going to be the 1100 picofarads. If we convert the picofarad into the microfarad, it's going to be the 2.2 and 1.1. Okay, and I'm not going to, so this is a just this website is a free website, but it's not a secure website inside, because it is a Chinese website. I'm not against that, but it is a Chinese website. Here they allow us to simulate the silent key low pass filter. Previously I have showed one with a PDF which has a lot of equipments attached to it, like a voltage regulator and other stuffs. This is the simplest one out of all, silent key low pass filter. Here this R1 is going to be 10 kilo ohm and R2 is also going to be 10 kilo ohm. C1 is about 2.2 microfarad and C2 is going to be the 1.1, which is connected to this operational amplifier op amp. So if we simulate it, we will get some results. So these R1 and R2, 10 kilo ohm and 2.2 microfarad and 1.1. These are the resistors and capacitors we need for our work. Next, we need a power to make these things work happen. Here I have chosen my own power supply unit instead of going with the battery, because of batteries will not last long for our testing purpose. That's why but anyhow, for the safety purpose, I'm going to buy the battery, 9-volt battery with the connector. And PCB and other stuffs I have already won that, so I don't need this. Total cost will around 1200 to 1600, but I think this cost is too high. So, because these reference marks of these prices for Indian prices is with the online price. I checked out with my local community on local shops, which is fantastic to buy this electronic because of I compare the prices with the online as well as the local shops. For the local shops, it is almost 10 times lower the cost. I got this for the 600 or 700 rupees, all these equipments under the 700 and 600 rupees with my local shop itself. Because if I have checked in the online, which even like by buying this microcontroller and ADC module itself will exceed this 1200. This is also the not an exact value. This needs to be revised. I have checked in Amazon where this microcontroller and the ADC itself exceeds the price of 1200, which which looks less suspicious to me. That's why I have considered and asked for the local shop, and I have ordered that within the range of 700 to 600 rupees. Good to hear. Okay, these are the equipments we need to be used for the MVP model. Next, we need to connect all those, and we need to check how it is going to be work inside our MVP model. I will show you here with my diagram itself. I have taken the diagram. I have exported, but the diagram is not by the websites, or else they did not exactly looks like a circuit diagram. I have checked for the online editors or else software IDE to create or a pinout diagram of the equipments I'm going to use, but most of them lacked features with the components I'm going to use. The photodiode and the ADC module, these doesn't present inside the website. And I also checked for the professional or else enterprise level applications or IDE to build an embedded system or to build an circuit. But they have the components present inside their IDE, but they cost very much. They are expensive. If you're an enterprise, you're working in a company with an enterprise scale, you obviously need that softwares. One of the thing I am mentioning here is a Proteus. Out of all other circuit websites which is present in online editor as well as software IDEs, Proteus looks way more professional and the enterprise because of they have the all the components, simulations, and apart from this, we can also external link to the signals devices too. So that's why I'm mentioning here. This is not a sponsor video. This is just mentioning the Proteus website for your use case. But since this is an MVP model, I don't need that expensive software IDEs to mimic that circuit diagram. Simply, I use the Figma to make the circuit. Okay, you can see this is a circuit diagram of what we are going to do. This is a laser, as you have mentioned, the laser which is nothing but 650 nanometer 5-volt red laser. It has 3 pins of it, which has ground plus 5-volt, but in some papers it mentioned the 3.3-volt is enough, or else above the 3 voltage to 5 voltage is good for it. But for me, variance of voltage will eventually affect the device or else equipment for the electronics consideration, because of prolonged use of variable voltage will eventually affect the device. That's why I'm stick with the positive 5 voltage for this red laser. Next, this is the linear polarizer film sheet, which is not rotated one, and in between the two polarizer sheet we are going to place a finger, obviously. After that, we have the 90-degree rotated polarizer sheet. That's why I mentioned a small gray rectangular box. After that, we got that photodiode BPBW34, which got the cathode and anode. For the cathode, we are going to provide positive 3.3 voltage, and the anode will provide the results. This result will be passed to the trans impedance amplifier, that MCP6002 DIP 8. I have explained in the earlier of this live itself, it has two stages, stage 1 and stage 2. In other terms, it got two amplifiers, two op amps present inside this one plastic chip. The stage 1 is used for the accuracy for the different skin tones as well as the blood flow. And the stage 2 is going to reduce the noise in the 50 to 60 hertz of hums, with the clean output will be passed to the ADS 1115 16-bit analog to digital converter. First, let me explain about the stage 1 process. This stage 1 process is an additional feature added by the Gemini response, added from the Gemini response. Apart from this, I only had the stage 2 response, or stage 2 methodology will be added with this BPW34. But for the different skin tones, it provided a great, wonderful idea to add a stage 1 process here. So since this MCP6002 debate consists of two operational amplifiers, one of the stage 1 is going to be used to analyze the different skin tones and providing the better accuracy, and stage 2 is going to be addressed as a noise cancellation purpose. The output from this BPW34 photodiode from the anode is going to be passed to the gain of the stage 1 amplifier here. V in negative, you can see this is the gain. So gain of this amplifier. Next, what we are going to do, in between, we are going to junction this gain with the V out along with a 100 kilo or else 1 ohms resistor. So this is any one of a one. This is not maybe 100 kilo ohm or else 1 mega ohm of resistance needs to be added in between the gain and V out. Further, the V in and VSS needs to be grounded here. This is the stage 1 amplifier. The output from the stage 1 from V out is going to be provided to the stage 2 noise cancellation purpose, stage 2 amplification process. You can see here. So here also we got that VDD, V out B, and V gain, and also the positive voltage providence. This MCP6002 is going to be provided with a 3.3 volt or 5 volt. Obviously, we need to stick with any one of the volt according to our application. Since it is a microchip with an op amp, I think 3.3 is good enough instead of going with the 5V. Maybe it will affect the device, it's fine. So I'm going to provide a 3.3V to the VDD of this 8th pin out. Next, what we are going to do is that V out, maybe you will be a little bit confused with this pin out here because of all the colors are in red. We don't know which is connected to which one. The VDD is going to be provided with a 3.3 or 5 volt. Next, the V in B positive is going to be grounded along with the capacitor of 1.1 picofarads. Sorry, 1.1 microfarad. If you convert it into it, you will get 1100 picofarads. Next, what we are going to do is that the V out and the V gain of the secondary V gain is junctioned with the capacitor of 2200 picofarads, and that 2200 picofarad is junctioned in between the two 10 kilo ohms resistor. This is also combined with the V out in. So this is going to provide the V out is going to provide the signal which will be passed series with a 10 kilo ohm and one of the thing is passed with the 2200 picofarads and is going to be provided as the V out. So V gain as well as the V out are connected with the one thing in a three different manner. First, it is connected with the V out as well as the it is connected with a secondary 1.1 microfarad capacitor, and it is grounded one side. And another is going or another side is going to be provided as a input to the ADS 1115 16-bit analog to digital converter. So this is, in other terms, it is called as trans impedance amplifier TAA in our process. This is going to be provided as an A note for the ADS 1115 16-bit. In this, we have different kinds of SCL, SDA, and ADR, which is nothing but the spikes and low spikes of the signals, digital signals we need to provide in different manners. That's why ADDR is grounded. SDA and SCL is provided to the ESP32 board. The D22 is inputted with the SCL, and SDA is input as the D21, digital 21 and digital 22. Inside this ESP32 board, we are going to calculate some glucose level. But from the starting stage itself, we don't have the capability to provide an accurate results, because I have asked about this thing in Germany. It says some external things like for example, it says in the first instance we will not get that exact result. This I have experienced this in my hackathon itself. So what we need to do is that with this MVP, with this secured MVP, first we need to grab some informations with different persons or different samples. We are going to grab those information. First, we need to grab some curve regions to calculate or to begin with a formula to calculate the glucose. That's what we need most. So this, as I have said, ACL, the clock line, and SDA data line. Okay. 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 So here it is a physics part. We need to understand that how voltage becomes mg and dl, which is nothing but inside a process. The circuit diagram shows like we are noise cancelling, and also we are providing accurate voltage level for different skin tones and blood flow for different persons. All this is passed to the ESP32. Now ESP32 got the data, accurate data, filtered and prepared by the previous ADS, MCP, and all the things. Now it got the data. This data is provided by this calculation regression problem is nothing but high glucose is calculated by more absorption slash scattering, less light hits the sensor. This is what I have said here. You can see we have, if we got the higher glucose molecules, obviously it will return the lowest light rays. If we got less absorption, then the more light will be passed through the skin and the finger and eventually hit the photodiode. We got the higher voltage. So more absorption scattering, less light hits a sensor, low voltage. If we got less absorption, more light hits a sensor, and we got the high voltage. This is how we are going to calculate the mg per dl. Like each and every mgdl has its own voltage levels. This also I have studied from the hackathon while I am doing this device at the time. So I have read the paper from Kaggle and other stuffs. We got the different voltages has the different blood sugar values. So this is the data we need to take from the ESP32, and we are going to process this data. For this voltage, we have get this glucose level. So this is what we are going to calculate. But without any proper calculations, with the blindfolded of this voltage to this glucose level is not going to be an accurate one. That's what we are going to further process this data with some formulas, or else with a machine learning models, we are going to get accurate results. Okay. So your record voltage is equal to 2.50 volt, means actual glucose level may be 110. This is just for the educational purpose, not is exactly the one. The actual glucose from the strip. This is from the strip, means the invasive method calculation. The glucose level may be 110 mg per dl. Your record voltage 2.30 voltage, means we are going to from the strip 140 mg dl. The higher the voltage level, maybe some fluctuations happen. After the 50 data points, we are going to plot them on the graph along with the invasive value as well as the non-invasive value. We are going to plot the graph and we are going to calculate the linear relationship between these values. Maybe I can show some of the examples which has taken from the hackathon itself. You can see some cost estimation, data sheet error, and validation sugar value. Maybe I open this sugar value. Okay. So invasive versus NIR. So these are the different volunteers provided for our invasive as well as the non-invasive methods. So here we have the different name, different volunteer persons with along with the name, and the NIR calculated value and traditional calculated value. So you can see the flow between these two things. We got different values. We got the average, and also we have read this. We got that plus or minus 5, plus or minus 10 tolerances between these in between the calculations. And also it spiked for some other persons and lowered for some other persons. We got a different results. But this is what we need. I think we need some other like, okay, this is the exact thing I'm searching for. You can see here, these are the NIR values continuously readed with one person or different persons for the prolonged amount of time, and we have also calculated the respective voltage for that. For the glucose value of 118 mg per dl, we got the 337 voltage. Consider this is a micro voltage. It is not going to be the exact voltage. Voltage is something but not like 337 volts. It's not like that. This is a point voltage. Okay. So keep in mind these are the micro voltages, not the exact point voltages we are going to get. So for this voltage level, we got these glucose points. You can see these things are calculated in a prolonged manner, and you can see some linear relationship between by analyzing this graph. We have the voltage 1 and the voltage 2 group, glucose 1 and glucose 2 values. So there is a, we don't have the exact curve value to form a formula in the glucose 2, but in the glucose 1 we got the exact curve value to analyze all the stuffs in one formula. That's why this is unpredictable in manner. So each and every glucose value has their own microvolts. Okay. So this is what we have got. And after calculating by the curve, we are end up with a formula like M into voltage plus C. So, but this formula is not going to be exactly provided and exactly used for the accurate results. First, what we are going to do, this is what we have done in the previous hackathon. We have blindfolded calculate all those values and we cannot provide the exact accuracy for our calculated. Now what we are going to do, first and main process, we are going to grab the voltage and glucose values from the inputs of those sensors. Sorry, yes, from the inputs of those sensors. And next what we are going to do, we are going to feed this, or else we are going to take this all those data and we are going to train our model. For this we are going to use XG boost ML. So first we will calculate. I have also coded this one with the help of Gemini inside my Arduino IDE, and I have compiled it, which is working fine. but I need to dump this inside the ESP32, and we need to form the circuit, which the formation of the circuit in a physical manner. I have ordered the those circuit components, but I need to assemble it. Once I got that order, I will make a separate live for that, connecting all those circuits into a board, and I'm going to sample test, and I'm going to run this machine or its MVP. I will make a third live about it. The training of this Python, for what we are going to do. First, we will calculate the average for, sorry, not an average, just for a thing I'm saying. First, we are going to calculate the samples we got, the voltage level with the respective glucose level for that voltage. We are going to plot all this inside a Excel sheet, and we are going to use this Python to test that Excel sheet data. So we got that voltage and glucose level data, and we are going to make a linear regression model. This, why, what is the purpose of this data sheet analyzing, and what we are going to do with it is nothing but simple. First, we are going to get the slope and interception between the glucose and voltage levels. I have I have opened that Excel sheet. You can see the slope or intersection between those molecules. For the first glucose voltage and glucose level sheet, we got that easy curve. Easy curve. I will open it once again. You can see the easy curve it's showing. But for the glucose level, it has some slope, and I think it doesn't got any intersection, but it got some slopes. Am I right? That's why we need the interception slope formula to calculate accurate results. That's why we first collect the data of glucose 1 and voltage 1, sorry, glucose and voltage, respective voltages for the glucose level. And we are going to fed into that ML processing, and we are going to get the formula or the value that needs to be mentioned in the slope and interceptor, and this needs to be implemented inside our code. Here you can see. So since we got that voltage level, we are going to mention the slope difference and interception difference values inside our code, and we are going to exactly provide the glucose value. This will be the output we are going to show in measured MGDL. Okay, but these values are just a dummy data. This taken by the Gemini by the calculations for that given, or else the response that it has given previous for the MGDL and voltage level, this one. But for us, we need to take some real world samples, and we need to get that average, sorry, we need to get that voltage and respective glucose levels, sorry, respective glucose levels, and we are going to place it on, and we are going to get the slope and interception values. Next, for this, to make an better accuracy for our model, to get that accuracy we desired, we need an AI upgrade here too. So we have already trained the XGBoost in Python. Now we are going to export that model, and that model needs to be dumped into the this ESP32. Because of the slope and the interception may change in future according to the latest samples that we are going to provide. But for the initial stage, we are going to take 50 samples with that, and that 50 samples with that we are going to train the model. But to get that more and more accurate value, we need more and more data needs to be fed into that model. That's how that AI and ML functionalities are working. We need, if we got a huge amount of data, we can get that exact results what we need by that huge amount of data. Because without a handicapped data, we cannot provide an exact results. That's why we need a huge amount of data here. So each and for to make an accurate results, we are going to feed more and more samples in future with that equipment, and we will train the model, and we are going to dump that model into the ESP32 to provide a better results. Since this model is going to be trained within our local region, so this may provide an accurate and high level values within the local region. That's what I have in mind. That's what a little bit of backdrop I'm going to imagine. But maybe it can change. That's all about this live. I hope you people have learned something new from this thing, from this live. On the next live, I will demonstrate how I'm going to set up that circuit after I got the order, and I'm going to test that MVP in a real-time manner, and I'm going to calculate all those data values and fed into the CSV file. And I will catch up in the next slide. Thanks for watching.